Welcome to Physics 1. This is Chapter 2, Section 2, Part 2, where we're going to be dealing with displacement with constant acceleration. So far we've only had a couple equations dealing with speed and acceleration. We've added a couple of equations here that we need to make sure we have on an index card so we can reference for our quizzes. And this is table 2.6 from page 54. So we've got delta x is equal to 1/2 the sum of the velocities, initial velocity plus final velocity, times delta t, or change in time. We also have the final velocity is equal to the initial velocity plus acceleration times time. Or we can use delta x, or the change in displacement, is equal to initial velocity times time plus 1/2 acceleration, and we can square then a change in time as well. And our final equation when we're dealing with straight line motion is the final velocity squared is equal to initial velocity squared plus 2 times acceleration times the change in displacement. So when you're working through the problems from this section, you'll need to find an equation that meets at least three or at least all the variables with the exception of one. So we want to make sure we're solving for one variable. Alright, so looking at a practice problem from this section. In England, two men built a tiny motorcycle with a wheelbase, and the wheelbase just distance between the centers of two wheels of just 108 millimeters, and the wheels measuring 19 millimeters in diameter. The motorcycle is ridden over a distance of 1 meter. We're going to suppose that the motorcycle has a constant acceleration as it travels this distance. So its final speed is 0.800 meters per second. How long does it take that motorcycle to travel the distance of 1 meter? And we're going to assume that the motorcycle is initially at rest. So looking through here, let's list our givens. Final velocity is 0.800 meters per second. Initial velocity is 0 meters per second. Our delta x, change in displacement, is 1.00 meters. And we're wanting to find our change in time. So looking at the equations from the previous slide, I've got final velocity, initial velocity, and delta x, and I want to find delta t. So it should be an easy giveaway to use this first equation, because the other ones contain acceleration, and we haven't really talked about acceleration on this problem that we're looking at. So I'm going to use delta x is equal to 1/2 the sum of the velocities we're going to rearrange the equation so that we can solve for delta t. And then we'll plug in our values and solve for time. So delta t is equal to 2 times 1.00 meters, dividing this by 0.800 meters per second. And we're adding 0 meters per second to that, so I'm just going to omit that since it just drops off anyway. So the product of the top divided by the sum of the bottom is going to leave us canceling the meters out. We'll be left with seconds. So my final result will be 2.50 seconds.